welcome back to Code Stack. If you are new here, do not forget to like, subscribe and turn on the notification bell. In today's video, we are going to learn about most powerful sorting algorithm, merge sort. Let's understand step by step in a simple way. What is merge sort? Merge sort is a divide and conquer algorithms. That means it divides the problem into smaller parts, solve each part and then combine the result. So why should we learn merge sort? Because it's not just another sorting algorithm, it's one of the most efficient and reliable algorithms used in computer science. Unlike simpler methods like bubble sort or insertion sort, merge sort work much faster on large database. Thanks to its divide and conquer algorithm. It's run in O(n) log n times, which means even if you have thousands of elements, it can still store them quickly and consistently. That's why it's widely used in real-world systems, like database, search engine, and built-in sorting libraries in many programming languages. Learning merge sort helps you to understand the logic and modern sorting technique and build a strong foundation of algorithm and data structures. Let's try to understand what is merge sort algorithm. Merge sort algorithm is a simple three-step process. Divide the array recursively into almost two halves until it cannot be further divided. If there is only one element in the array is already sorted, return. Last step is merge the smaller sorted arrays into new array in sorted order. We will understand each and every steps in details. But before, let's understand basic jargon, which we are going to use in our implementation. Let's take one example. Start index 0 labeled as low and last index 6 labeled as high. Index 3 is mid and index 4 represent mid plus 1. We will see how we are calculating mid and mid plus 1. This is the logic which we are going to use to calculate this mid for the array. Pay attention guys, this is the right way to calculate the mid index of the array. Please do not use low plus high divide 2. If will overflow, for large input always use this. Divide the array recursively into almost two halves. Let's write the method for it. First, so we have method name merge sort, which accepts three parameters: input array, start index or low, end index or high. As we need to divide the array almost two halves, so we'll use this formula to calculate the mid. Now we know the mid. Let's divide the array recursively. So we'll call the same method but with different parameters. After dividing the array, our mid will become high for left half. Call the same recursive function again for second half for right half, the array with mid plus 1 as low. So far we have written an algorithm to recursively divide the array, but it will go into infinite loop without a base case. So we have to add base case as well. If there is only one element in the array, it is already sorted, so no need to think, just return. And how you will come to know there is only one element in the array? When you reach to the point where low and high both are representing same index or point to the same element. It means there is only one element left in the array and single element always sorted. So let's add that condition here. If low is equal to high, then return. Here base condition is init block and rest statement are in else block. So we can just write the same thing like this. If low is less than high, then else statement should execute. By doing this, we are reducing this conditional block. Because low is shift towards right side and right side will shift towards and once both meets in mean, we have traversed all elements in the array. So far, we have completed the two steps. Let's talk about the third or the last step. merge the smallest sorted arrays to new array in sorted order. So here we'll merge the two sorted array in sorted order. Let's understand this merge sort operation in detail. First then we'll see the complete merge sort visualization. Here is the code which will perform merge operation. We'll understand this with the given example on left side. We have give two sorted arrays and we'll merge this into one sorted order. First create the auxiliary array and copy all the elements from the given array. So this code is doing the same thing whatever I just said. Copy all the elements from the given array to auxiliary array. So now this auxiliary array also have two sorted arrays or partition. Let's take three variables I, j and k, where I is used for start index or log. The auxiliary array j is used for mid plus 1 in auxiliary array and k is used for start index of input array or log. Let's run this loop from low to high for input array. In first iteration compare ith index of auxiliary array to jth index of auxiliary array. Conceptually both are representing the start of two different sorted array. If you compare those two values, one is lesser than 2. So we'll put in original array at the index k and increment j and k accordingly because we have put the j index value at proper place in the array. In iteration 2, compare those two values. 1 is less than 2. So we'll put 1 in original array at the index k and increment I and k. Accordingly because we have put the jth index value at the proper place in the array. Similar for third iteration, compare those two values. 2 is lesser than 5. So we'll put 2 in original array at the index k and increment I and k. Accordingly because we have put the ith index value this time at proper place in the array. Similarly for fourth iteration, compare those two values. 3 is lesser than 5. So we'll put 3 in original array at index k and increment j and k accordingly because we have put the ith index value this time at proper place in the array. In fifth iteration, compare those two values. 4 is lesser than 5. So we'll put 4 in original array at index k and increment j and k accordingly because we have put the j index value time at proper place in the array. Similarly for sixth iteration, compare those two values. 5 is lesser than 6. So we'll put 5 in original array at the index k and increment j and k accordingly because we have put the jth index value this time at proper place in the array. For seventh iteration, there is nothing to compare because we have exhausted jth index. So now j is greater than 100. It means all the elements of the right half got placed in correct position in the input array. So let's copy the left half remaining element into the original array and vice versa. It means by any change left half got exhausted, first we can directly copy the right half of the array. So we'll copy the sixth index k and increment I and k accordingly. In 8th iteration, loop condition is false because k is greater than 1. So control will come out of the loop and see the original input array. It's in a sorted order. This is how the merging happens between two sorted arrays. Here, two sorted array does not mean it should always be two different arrays. If maybe two partitions inside the same array as well, just like we saw. We have seen the one array into two different sorted partitions. Divide via midpoint or index. The same operation has to perform in sorted partition and form a big one, which will be used later for merging with bigger partition. On the left side we have code and we'll trace out for you to make the things clear. Low is less than high. It is true, so divide the array into two halves and recursively do the same until it cannot be further divided. So we'll keep on the dividing array. Now let's divide this in next step. Here we have reached to the point where we cannot divide the element further. And low is equal to high, so this condition is false. Now recursion will start folding and will perform merge operation. Let's see the merge code as well along with this diagram. Here 6 and 3 are two different sorted partitions in the array and merging will happen for those two. And you will get one started partition which is this. Here merging is performed on left half. Now right half will be processed similarly. Divide the array first until it cannot be further divided. And then start merge operation. Here 2 and 4 are two different sorted partitions in the array and merging will happen for those two. We cannot see any changes here because both are at their proper position or already sorted. Now we have two sorted partitions on left side, so merging will happen. We will use the same merge operation which we discussed initially. And those two small sorted partitions will be merged in a sorted order. Now control will go to the right. Now same thing will happen again. Divide the array recursive till it cannot be further divided. Now left half will be divided first and merging will happen on left half first. Here 1 and 5 are two different sorted partitions in the array and merging will happen those two. We cannot see any change here because both are at their proper position or already sorted. Now right half will be processed as there is nothing to divide, it will return the control. And merging will be performed with the last left half which is this. Here 1, 5 and 1 are two different partitions in the array and merging will happen for these two. And we'll get one sorted partition inside the array. Now we have done with the left and right half. This is the last step because now both partitions or array halves are sorted. One thing to notice here, we have two first in the array and both are maintaining its relative position. It means the one highlighted with yellow comes before the one which is highlighted in blue is in the given array. Which shows merge sort is a stable algorithm. It will not change the relative order of the element if duplicates are present inside the array. So once again final merging will be performed to get the input array sorted. And this will be the final result. Here we have got the input array in sorted order. See the 1-minute animation video which is doing the same thing what we have just discussed. This is the program guys which you have already seen in last couple of slides. So I will not talk much about it. It is the same code which we have already seen. So I will just run this program in front of you to showcase whether it is work or not. So let's start. I will enter the number of elements in the array, let's say 8. Now I will enter the 8 elements 3, 5, 1, 6, 8, 9, 0, minus 3. So now the sorted array is this. You can see guys, this is the input array which is random. And this is the sorted array, it means our program works fine.